Take 87. What we have is the real sun. I've got 4 mirrors, 4 true reflections, right, of the sun. So finally, the solar eclipse did it, or did it not prove that the sun's light travels at 299,792 kilometers per second, or did it not prove that the sun's light is absolute? It kind of did neither of those things, did it? Because we don't have the instruments. All we have is our common sense and critical thinking skills. Did I actually say that? Let's have a quick snapshot of what's happening first. For me, la luz es absoluta, absolute light, right? I think it's fairly obvious, but just because I think it's very obvious, without the evidence is there, and we will find it eventually. Planet Earth. In one day, we're going to look at the moon and planet Earth. One day, planet Earth spins on its axis 360 degrees. Right. The reason we want to know, we're going to break it down into an hourly rate to know what is moving how much. Right, so we've got planet Earth, and we spin in an anti-clockwise motion like that, which is clockwise. We go that way, okay? So let's go America there. Right, so in 24 hours, we do 360 degrees. Right, in 24 hours, we spin 360 degrees, which is one day and one night. In that one day, the moon, I should get this out, the moon spins, it doesn't spin on its axis by 13 degrees, it's tidally locked to planet Earth. So its face, you hear about the same face, is always facing Earth. So in 24 hours, it moves by 13 degrees like that. But it comes about like this. Obviously a lot further away, but like that. So that's how much it moves. That's the spin, right? 13 degrees, but as it's tidally locked to planet Earth and a lot slower than us as well. So we go like this, and the moon just goes really slow, like that. And 360 degrees in 24 hours. This does 13 degrees, tidally locked to planet Earth. Oh, there's Alexa, what distance does the moon move every day?
From Quizlet.com, the moon moves about 12 degrees per day.
12, okay. Alexa, how many kilometers does the moon travel in 24 hours?
This might answer your question. The closest answer I know is from today, when the moon will be 397,000 kilometers from Earth.
Yeah, okay, I think we'll quit while we're ahead, okay? So, we've got Earth spins on its axis in 24 hours by 360 degrees. The moon spins on its axis by 13 degrees, but it's not just an axis spin, it's the orbit around planet Earth, and the axis spin is because it's tidally locked, so it goes like this, right? 13 degrees. If we divide 360 by 24 hours, we get 15 degrees every hour. Planet Earth rotates 15 degrees every single hour. 24 hours, 360. If we divide the 13 degrees that the moon swings around, we divide by 24 to find the hourly rate, we get just over half of a degree, 0.54 of a degree, all right? We could do the whole 90, because I said 90 minutes, the eclipse lasted 90 minutes, right? So I was gonna get the amount turned on their axis in 90 minutes. So we've got an hour, it's 15, we want another half of that, right? So we divide it by 2, and we get 7.5. 7.5 to 7.5. To get an hour and a half, we had another 7.5. Earth spins on its axis by 22.5 degrees every 90 minutes. Do the same to the moon, divide the 13 degrees by 24, we get 0.54, which is just over half a degree every hour. We want to add another half an hour onto that, so half of 0.54 is 0.27. Add them together, we get 0.81 in 90 minutes. So Earth on its axis, 22.5 degrees. The moon on its axis in 90 minutes, 0.81 of a degree, not even a degree, right? Now this is important. See, look how those suns have already moved. Now, what's important here, and the reason it's important, is because all of the action that we see around us, like the sun, the moon, everything moving, it's mainly because of planet Earth. Planet Earth is the mover and the shaker, ladies and gentlemen. The moon, it really doesn't move that much. The sun, look, if we were locked in that eclipse position where the people right beneath the moon in the direct line had the sun above them and they had the moon, the outline of the sun, right? If we were locked, if planet Earth stopped spinning on its axis when we were in that position and the moon just froze and we just waited for the sun to move one way or the other to know what it was doing, how long would we be stuck in that shadow? It's so far away, it may as well be a structure, a fixed structure. For this 10 minutes that we're talking about, we'd never see any change. If you come out here tomorrow at this exact same time and you look for the sun, it will be in the exact same spot. It won't be, but the difference, we're probably talking arc seconds. It's that far away. So the sun's light is basically a constant, right? And it's coming from a fixed address. So all of this 8 minutes and 20 seconds away when we're looking at the eclipse, and the sun's 8 minutes and 20 seconds that way, or the moon's 8 minutes and 20 seconds late, and no way. The sun is static. It is not budging. It's planet Earth spinning on its axis that causes that sunlight, and there it is. So they're caught in the eclipse. They're protected by the moon. Look how long it's taken. I mean, this is a mirror and it's bouncing, but it's live, isn't it? So now those people that were here, right in the middle, right up this corner here, and the sun's coming out again. And those people, right, it's quite good this, those people who were protected, right, from the sun, are now exposed to it because, and it looks like it's the sun that's moving, but it isn't. It's planet Earth spinning on its axis. Therefore, your 8 minutes and 20 seconds variation between the sun and the moon and the sun and everything in between is horseradish, right? Because there is no lateral movement occurring from the sun. It is because of Earth's spin on its axis, right? Now that should be fairly settled. I know some of you aren't going to like it, but it's a fact. We would not see the sun move, all right? So forget the 8 minutes and 20 seconds further down there, because it's not. The sun hasn't moved. It's planet Earth that spins on its axis. It hasn't given us a definitive answer one way or the other, but it's taken a few points off of 299,792 kilometers per second. And absolute is still just waiting, because it will become apparent. We will just keep chipping away. The one thing that you can do though, that ridiculousness, right, of a beam of light. If you hold on to a laser for X amount, let's say for 1 minute, right, from planet Earth. All right, let's just say, I don't know, Jupiter for fun, right? It's not orange. Let's do Saturn instead, eh? Let's do Saturn and its rings, so we start with a bit of green. So you've got Saturn up there, and you've got a really powerful laser, and you're down on planet Earth. right? And you get that laser and you point it at Jupiter, right? And it goes, everybody's saying it does this, right? And keep going, keep going, keep going. 299,792 per second, right? But what's being said is, let's say you let it go for a minute. Let's just take, for example, a minute's there, right? So you've got a beam of light from there to there. And what they're saying is, you turn the laser off, that beam of light continues without the source, right? So in X amount of minutes or an hour and something, it will get to Saturn. And somebody will go, oh look, there's a 1 minute beam of light coming from Earth. But how do you know it's for 1 minute? Oh, yeah, whatever. No. If you've got a laser and it's going to reach Saturn, it needs to be, it will be powerful enough. If it can reach Saturn, it will reach Saturn in a heartbeat. Boom, like that. If you turn the laser off, everything disappears, the beam disappears. It doesn't have thrust. It doesn't have thrust, right? This, if the sun turned off, this is how it started, right? If the sun turned off, the delusional was saying 1 minute, 2 minutes, 3 minutes. Let's say it turned off there after 3 minutes of a beam of light, right? What am I doing? It's been that long, I forgot I did these. There's your beam of light. Because what is being said is there is a physical measurement that you can actually break down to the meter, because it's 299 million meters, 792,000 kilometers, and yada yada yada. What was it? 584 meters or something, down to the actual meter per second. So basically, you could break down, you could pinpoint meter perfect, right, where the beginning of your ray of light is and where the end of the ray of light is, because you've got it down to the meter. My question, first question is, right, how on earth does anybody measure this when it first takes off, right? How do you get in front of it to measure the speed of light? You can't measure it from the side and you can't measure it from behind. So exactly how? See? Oh yeah, but they spun mirrors, they did this and they did that. Did they really? I haven't seen, has anybody seen one single calculation with all of the actual numbers, the reasons why the numbers were used, the method that was used, and why they did every part of the equation, right? And with supporting numbers. There isn't one out there. There is not one out there. People have said there is. I had somebody send one in, and it was from the get-go, right? People aren't able to work out the speed of light because they tripped over a bicycle and they saw a passing bird, and it just so happened to block the sunlight out for a second. It's just, all of these stories are ridiculous. There isn't a working out of the speed of light anywhere, and if there is, I've yet to see it. My common sense tells me, first of all, how do you measure something that you can't keep up with, right? Straight to the basics. How do you measure something if you don't know how, you can't catch it in the first place, and you've got no idea how fast it's going? How do they do it? How do they do it? Break it down. What did these spinning mirrors do? Did they bring it down from what? How did they know even where to start? Don't say Roma. Don't say Roma, or somebody's going to get thrown off of the bus. All right? All of it. It's absurdities, right? So you've got this physical beam of light, right? It leaves the sun, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes. Oh, let's just say he turns the source off. What is being said, so let's say see that line, that's where it's off. So this is like the light beam. He turns the light beam off and people are saying, or academia, or someone, oh, yeah, okay, we know who it is, but the light will go like that and keep going without the source behind it. And when it, it just keeps going until it bumps into something. It just keeps going until it bumps into something. If that were the case, we'd be seeing flashes of light. New flashes of light all the time. We don't see any new flashes of light. Why aren't we seeing flashes of light of other stuff that's happening now, not in the past? There's no such thing as looking through a telescope into the past. I think we should focus on that one as well soon, right? Without the source turns off, the light goes out, it disappears. It doesn't, wait, has it got thrust or something? Right? How do we prove this? Well, there is no front or end to light, right? It's absolute. It doesn't have a pointy bit, right? And then an end bit, like a tail, when you let go of the laser, the switch. It's not like a little tail that you can, oh, there it goes. It's ridiculous. I mean, this is the brains of the outfit talking this stuff. Where's the evidence? The evidence is common sense. Alexa, can light travel without a source?
From LiDARradar.com. Light is capable of travelling without medium because it may be generated and propagated through vacuum or no medium.
No. Alexa, if I fire a laser into the sky, when I take my finger off the button, does the laser light keep on travelling? It doesn't.
From thetruthaboutguns.com. When the button is released, the light will shut off automatically.
Alexa, if I've got a powerful laser pointed into the sky, when I take my finger off of the button, what happens to the light? Does it continue?
I don't have an answer for that.
Alexa, I'm shining a laser into the sky. What happens to the laser light when I take my finger off of the button? Does it continue?
I don't know that.
It doesn't. How do you know? Where's your evidence? I don't know. It just doesn't. Alexa, can light travel without a source behind it?
From Chirito.com. Light can travel through the vacuum.
Alexa, if I have a laser and I'm holding it up and I fire a laser beam out of it, when I take my finger off, does the beam still carry on moving?
From Canada.ca. The laser emits a very intense beam, which will travel great distances, while maintaining a size and strength as it travels, due to the very small beam divergence.
Oh, Alexa, but what happens when I take my finger off of the laser button?
According to Mayo Clinic, over-the-counter drugs such as acetaminophen, naproxen sodium, or ibuprofen may help for pain. For injury pain, self-treatment also includes rest, ice, and elevating the injured area. Contact your doctor if you are seeking medical advice
Alexa,
for you or...
I'm holding a laser beam and I'm firing it up into the sky. What happens to the laser light when I take my finger off of the button?
Sorry, I don't have an answer for that.
Well, that's the best we've got. So, I mean, who's she going to go with? She's biased, we know that. She's not objective. No AI is objective. God, go get yourselves into a mess with that one. AI is going to start throwing the children off on the bus. All right. We'll be back.